Hey everybody, welcome back to Polybridge 2. In this video I'm going to attempt to show you everything that I did in World 2. You remember from the previous videos, first I did World 1, then I skipped and did World 3, and now we're back to World 2. This may be a longer video because I did do several of these levels multiple ways and do want to show it off. Let's jump right into it, and hopefully I can get this whole recording done without interruption. Let's start with 2-01 Unity. Basically, both the cars have to get across the bridge and hit their goal flags. The only thing that's even slightly complicated about this is that your clearance right here has to be tall enough for the tow truck to get under it, and it has this little light tower. It's really not that hard, and let's just run this so you can see it in action. There's your critical clearance right there. And the Model T luckily does not turn turtle and flip over on its top. Easy enough, right? So this is what I call the obvious solution, and if we go to load lives you'll see the obvi. But I also decided that the stress was a little bit higher than I really wanted it to be, so I did a hipster arch version with lower stress. You can see that this bridge is arched, just so that there's a little bit more compression on these pieces of normal road right here. Normal road is relatively strong in compression. And you can see those go just a little bit orange, but mostly they're green and yellow. So 78.3% stress, and it's still $9,000 under budget. Long drawbridge. You can see that we've got some relatively heavy vehicles over here, a 10 polygram fire truck and a 6 polygram VW bus. Again, this is just a relatively simple arch bridge. One thing I do like about this level is that they gave you 2 anchor points over here, so if you want to build a steel tower and maybe try to do some cables or ropes, you can see they gave you rope, then you can do it. I guess the challenge here was that they only gave you 8 pieces of steel. I only really needed 2 pieces of steel, so let's run this and you can see that it does work. And you do get some orange stress in here. And yep, the pirate ship does just barely clear. But it does. Very standard wooden Warren triangular truss over the top. You could do this more easily with a wooden diamond, and because steel is 450 per meter and wood is only 180 per meter, it's less than half. Even if you have to do a wooden diamond, it still ends up costing you less to build that wooden diamond out of double the equivalent linear feet of wood. And it's still plenty strong. Oh, in terms of this, calling this a diamond, I did want to show you something. If you look in the help here, so this is actually pretty interesting. Tip number 10 says diamonds. And they're talking about this thing that the Polybridge community usually calls mussels, but I've taken to calling them diamonds because they look like diamonds. It's good to know that I actually am not the only one who calls these diamonds. The help file in the game actually says diamonds. So for whatever it's worth... Okay, sorry about the diversion. Let's go back and look if I did this more than another way. Nope, it looks like I only did this one way. Let's go ahead on to the next one. Now, the interesting thing about this one is just that the limo has very low ground clearance and it's very long, so you have to make your curves be sort of very sweeping and gentle. And that's pretty much what I did here. Let's just show you this works. Of course, they force you to go low to collect the star down here. can see that just barely cleared right there. Ah, now, this is the first interesting one. I get this in frame here. You've got a buggy on a ramp. You can see it's a maximum speed of 12 meters per second, which is pretty quick. These buggies also have great acceleration, 8 meters per second squared, and great horsepower. Basically, this guy will pick up speed coming down here, and then he'll jump, and he'll hit this little ramp that sort of helps him maintain his height, and then he'll come onto this little ramp. And before we look at this mechanism, let's look at the obvious one. Barely makes it and over budget. You can see I just made a little bowl or dish out of reinforced road here. Tried to support it with some springs so that it would handle the shock of the car landing on it. And let's just see how this works. So yeah, that landing was a little rough. He almost fell back into the water. And not only that, but it's $3,000 over budget. Max stress 56 is nice, but yeah. So let's load up, barely makes it under budget. Used regular road, and really that's about it. And now I'm $1,000 under budget. Let's see if anything breaks. Oh. But I said to myself, you know, I can do better. And one of the crazy ideas I came up with was, I just felt like the buggy had all this kinetic energy coming down here, but then it was only barely managing to carry the energy through. So I said, why don't I add some energy to the buggy? I mean, I've got all these springs. Why don't I figure out a way to add some energy by putting some kind of a spring cannon over here? Spring cannon, hilarious failure. This was my first cut at it, and the way this works is the buggy jumps over here, it jumps off the little height maintainer platform, and when it hits this, it compresses the spring, and these two pieces of wood scissor, and which causes that node to go left, which pulls on this rope and pulls this trigger and allows this pre-compressed spring to push this platform upward. And there's sort of a delay as this little trigger mechanism, this little wooden diamond here, sort of spins around and allows the spring to go. And that's just enough delay for the buggy to get from here to here. It's going pretty fast. Let's take it for a spin and you'll see what I mean. Woohoo! So, fun. You can see it went way, way above. Like, there's no problem. That thing is throwing the buggy way up. But it did break. So, let's try that again. This time without the breakage. Spring cannon, hilarious success. Boom. I love it. I think my idea about using a spring cannon here to add energy and height to the car was a really good one, and I'm really pleased that I was able to make it not break. And lastly, let's just talk about making it easily. So, sort of not a spring cannon per se, but just a spring platform where the energy of the buggy compresses it a little bit and then it gives a little bit of that energy it received back to get it up and over. Yep. So, makes it easy, but it's just a little bit over budget. Makes it easy, under budget. You can see this is only 12,000. You know, I just took out sort of redundant or stuff that didn't need to be there, made everything a little bit cheaper. Makes it easy. All right. Not a particularly interesting level. Give you this sort of long span. You've got a relatively heavy 14 polygram articulated bus here. The budget's not enormous, but I managed to get under budget. Let me just show you that it works. Just one more thing before we actually run it. This is sort of classic wall bracing. You essentially shorten your span by a couple roads just by using an anchor against a wall. In this case, we have actual red anchors, but you know, you could just use a regular wall brace. So the point is, this span is now shorter and doesn't have to support as much weight, so you can use less expensive braces from below to sort of keep the whole thing together. Not a lot to say about it. Kind of a basic bitch bridge, but 75% stress, under budget. I'm not unhappy about it at all. This is kind of funny because you notice here that the way this is supposed to work is vehicle A is supposed to collect A1 first, at which point it will turn around, then collect A2, and then collect A3. I don't know who designed this level or what they thought was going to happen, but let's watch this thing collect the checkpoints in the wrong order, and I'll still get credit for doing the level. And nothing creative about these bridges that I've built. They are absolutely bog standard Warren overtop compression wooden truss. The only slight twist is that when the monster truck gets over to here and turns around, it needs to go back down to the bottom so it can get to the flag. So this hydraulic just lowers the bridge span down until it locks into this joint. Now, I did actually get a little bit more experimental on this one because I saw an opportunity, to sort of support both these bridges in a different way than using standard over-the-top wooden Warren compression truss. My first impulse, if you will, was to use crisscross truss, or X-truss, depending on what you want to call it. And so I just used steel crisscross or X-truss, and this works very, very well. Very strong, very low stress, very simple, works very well. I also said to myself, we could totally do a cable-stayed design on this one. I didn't actually use cable for budget reasons because rope is like half the cost. I just used ropes. I did a strong truss on this above and then just supported these with rope. And let me just show you how that looks. There you go. And then to economize over here, instead of a piece of steel from there to there. Second. So I had this. And that was fine, nothing wrong with that. But even using a wooden diamond, because wood is only 180 per meter, and steel is 450 per meter, is just a little bit cheaper. To do that. I did because I could. A little bit of an engineering flex or budget flex there. And I'll just show you that this works. You can see it's well under budget at about 22,000, call it. See, those ropes work very well. There's no significant stress anywhere on those. And then I wanted to try one more thing, which was instead of using steel for my X trusses here, let me load it up. So you can see wood is not long enough to reach all the way down, so instead I use these X trusses, which are sort of like... This one is just your sort of classic triangular Warren truss. I don't claim to fully understand this. I think what's happening is that when this node gets pulled down, these two nodes get pulled further together, and as a result, they try to compress through these woods here. They try to compress this road here. Yeah, I don't fully understand exactly how this X truss works, but it does work, and I'll show you how it works. It works very well. Distributes the load shockingly well. let's move along. Ah, this one's kind of fun. So you have a bus up here on top. It's a heavy guy at 10 polygrams, and it needs to make it to its flag over here. So you got to stay on top the whole way through. And then you have a fast red car, which is only 4 polygrams, but high acceleration, high horsepower, and goes fast. And then you've got a slow but heavier limo, and they have to stay on this bottom span and get to their flags down here. As you can see, there's a big, long span. It's a very long bridge. And my first cut at this was just use steel as much as you can with the anchor points you've been given to sort of shorten up your actual spans and support the over-trussed bridges as well as you can. And this certainly does work, and it is technically under budget. And let me just show you that it does work. Look at how fast that red car goes. There's definitely some red-orange up here. But I said to myself, you know what? X-Truss worked out so well in the previous level. Doesn't this look like it's just begging for some kind of X-Truss? So I think the first thing I did was use steel to make the crisscross truss, and steel is expensive. But as you can see, what it did was it allowed me to completely eliminate any kind of trussing over the top of the top bridge. The trusses really don't get that high. And if you are a 90s kid like me, you've probably been thinking about a funny little pop band named Crisscross, because I've been using their name in the names of my bridges, Crisscross Truss. Before we get to the RCE propaganda, let's go ahead and look at Crisscross Truss with wood supports. As you can see, this is under budget, whereas the Crisscross Truss with steel supports was over. Just made a little tower down here out of wood. Really the same thing as the previous way, just using wood where you could use wood, getting in under budget. And so the last thing I want to show you, you probably saw it when I was loading up bridges, I did make a full cable-stayed version with RCE propaganda. It's well over budget, but that's sort of the point of these, is when you put RCE propaganda in it, it's supposed to be way over budget, so that he can see it on the last page. Yeah. You were pretty sure it was going to be a Laldong, weren't you? Wouldn't be RCE propaganda without a Laldong. Oh, by the way, if your wang comes to a sharp point, you might want to see a doctor about that. That's not healthy. Ow, my nut! This one's just basically an airplane flies through the middle, so you can't do cable stayed on the lower bridge. Or if you do, you're going to have to be super clever about it. This is the one that I did first. I just put a big over-truss bridge with reinforced road and an arch, so that some of the force would be compression on these pieces of reinforced road, and everything else would be taken up by the over-truss. And then this one was, again, just a simple under-truss. You could totally do this with steel if you wanted to, but they only gave you 8 pieces of steel, so you'd have to be pretty clever about how you used your steel. And we'll load that up in a second, but let me show you that this one works. I found the best way to use the steel was just as sort of a compression support here to keep the top bridge supported. sort of shorten this middle span by knocking out the two on the edges here. Only the middle span is supported by the wood. And then the other sort of tension down here that just misses the wing of the airplane, and then a typical wooden truss. Let me go ahead and speed this up. Not a very interesting level, in my opinion. Only one wrinkle to this. If this wooden undertruss is supporting these, then why do you need this stuff? Can't you just delete that? Let the rope support the whole bridge? Sounds good, except one thing. Notice that there's no red anchor over here. So this node and that node are not anchored to these planks or roadways in any way. You want to guess what happens when this relatively heavy 5 polygram truck goes onto this piece of road and there's nothing to anchor that node there? Yeah, that doesn't end well. So here's how it looks with correct anti-sway support. And then I did a tension only with no wood, just using ropes. The way this works is basically when the weight of this truck gets on this piece of road, it pulls on that rope, but that essentially tries to pull up this edge, which is held downward by that rope. So these two ropes down at the bottom are the anti-tip. And again, let's delete these and we'll run it and you can see what this looks like. The bridge stays flat, but... yeah. So yeah. You may not think you need the lower ropes, but you do. And honestly, I like this solution. I think it's kind of elegant. Let me show you the especially low stress one. Now in this one I went out of my way to try and make everything as low stress as possible. I only had to use rope here because these are slightly too long to be a wooden piece. So let's see this, and down here you can see the stress number when I do the simulation. Keep an eye on that, and then we'll also look at the end screen. So under budget and max stress 57%. What can I say? I love it. I think it's great. And I visually enjoy this sort of arrowhead looking thing here. I think that's kind of cool too. So this is kind of an interesting one. The orange dune buggy has to get to its checkpoint up here, and then after that, the Model T has to get to its checkpoint down here. So what I've done here is essentially built a ramp right here, but as I show in the load, see this says works by accident. The reason that this works by accident is because this little ramp thing is in the process of continuously collapsing, and it's just that it happens to take long enough to collapse that the dune buggy speeds up here and gets up and over it before it collapses. Let me show you what I mean. See how this is slowly collapsing? So yeah, it works, but it really only works by accident because the collapse takes a long time. So I tried to do it again, and this time works by design. In other words, this time, when the buggy rolls up here, it jumps off this little piece of road right here is hit by the front bumper of the buggy. And it actually pulls on this weird wooden thing and pulls this leg out from under the ramp, causing the ramp to collapse and the Model T to be able to get up and over. I think I'm over-explaining. Why don't I just show you? Buggy hits this, kicks the leg out, and now the Model T can get up and over no problem. Okay, fine, but there's a broken piece of wood right here. So we can do better. We can do this without brakes. Works by design, no brakes in the materials. The key obviously was springs to make the impact of that buggy less severe and less likely to snap pieces of wood. Fun little thing, you know, sort of teaches you a new mechanic maybe, depending. Maximum stress 73, well under budget. Air show! First, the motorcycle goes over the top, then the airplanes fly through, then the motorcycle goes back, forcing you to build a bridge that won't be destroyed by the aircraft as they go by. And you notice that they gave you hydraulics if you wanted to try and do this with hydraulics, but as I said in my save game, we don't need no stinking hydraulics. Who needs your fucking hydraulics? We don't need them. We're engineers. We know how to use our materials in ways that build strong things even out of imperfect materials, or without flashy whiz-bang technology. And then I said, all right, you know what? You gave me hydraulics? Fine, I'll use hydraulics. And I'll just show you the sort of final iteration. I won't show you the over-under budget. Just the final iteration that I did that is under budget and only has 77% stress. Using steel diamonds here as towers. Hydraulics pull up the bridges from this node. There's your split joint right there where the bridges split apart. And just, you know, economizing as best I can, using rope where I can, because cable is rather expensive at 400 a meter. Rope is only 220 a meter. The only reason that these reinforced roads are here is because if you put regular road there, the stress gets rather high, I think, you know, 99% or something. These guys are stressed because they're taking all the pulling force of the hydraulics to pull up this whole section. The thing is, you can see that there are these sort of wall brace sections of bridge here that are attached to static anchors, and so these parts don't have to move. They're just shortening the middle span to make everything easier. Just barely makes the budget, which is okay. And maximum stress 77%. And uses the hydraulics, even though you don't have to. This is a really interesting level. You can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces of road. You can see that there's no more road available. You only get 9 pieces of road. The other thing that is unexpected is you might think that this guy cranks up its engine and just goes zoom, because dune buggies are very powerful. See the speed reading there of only 1.5 meters per second? This dune buggy has been made extremely slow by some sadistic bastard who designed this level. However, if you look down at the very bottom of that little square with the dune buggy stats, it says idle on downhill. That's the key to this. When this thing is going downhill, it will allow itself to speed up as it rolls and idles downhill. So the trick becomes, you only have 9 roads. How do you arrange the 9 roads so that the buggy has enough speed just by naturally rolling downhill to make the big jump and get down to the flag? This is one way you can do it. Let me prove it. Alright, it ain't pretty, I admit it, but it does work. And the max stress is only 66%. I looked at this and I said to myself, can't we do this with only 8 roads? Can't we just flex a little bit and do this with only 8 roads? Yes. Yes, we can. Like this. Now, you can see it doesn't actually make it to the flag, it turns turtle and stops. So, although technically it made the jump, it didn't make it in a way that allows it to complete the goal. So let's fix that. And the ultimate evolution of that after tweaking and, you know, making everything out of wood that could be made out of wood is something that costs $14,000. And, well, let's see if it makes the jump. I'll take it. 8 roads. 1, 2, 3, 4, 5, 6, 7, 8. Admittedly, one of them is reinforced. Used wood wherever I could. Just a little flex there. So this one was interesting because when I first saw this, I didn't realize that both trucks had to touch the star. I thought only one truck had to touch the star. And so my first attempt was like, oh, well, this is really easy, you know? We build a double arch bridge, we do some crisscross wooden truss, both trucks get where they're going, and this guy collects his star on the way, and easy peasy, right? Whoops. So my first impulse was just to do, I guess what you would call, I don't know what to call these, like, there's a thing that I do when I sometimes do an experimental bridge just to test out some kind of theory or approach, and we'll see this again a little bit later on in the video. In this one, I actually built a restraint device that would stop the semi from getting onto the bridge just so I could test out some other things with the smaller truck. So this is, hold me back, bro. Reinforced road cable and this steel triangle attached to these 2 strong anchors prevents semi-truck from going onto the bridge, and then just did a cable-stayed arch just to see if this truck could make it across like that. Eventually I went back to the crisscross wooden truss. Relatively cheap, 11,900 out of 20,000. Just made this arch down here tall enough so that the tall cab of this truck could touch the bottom of the star, and made this one just low enough so that this truck front tire could just barely touch the top of the star. You do have to be careful about your clearance right through here, because you can make it too low here, and then the tall cab of this truck can't actually get through your low headroom gap there. Nice. So, I had a really good time with this level. In fact, because I believe this is, what, 214? Yeah, I thought this might be the last level of World 2. And because of the large number of materials you're allowed and the relatively large budget and all the anchors and stuff, you have a lot of room for creativity in this one. You can see I used a lot of different things. I used wood, I used ropes, I used hydraulics, I used steel for this footer down here. I even used cable to support the hydraulics. Let me just show you that this actually works. The only crucial part of this is the clearance right there. The ambulance has to be able to go under the balloon. Other than that, so yeah, fun level, lots of room for creativity, reasonable budget, just fun in my opinion. Also, I'll show you one little thing here. I actually did what I call a cheaty version of this. Explain why it's a cheat when I bring it up. So, I don't know if you can see right here. Not only does this joint uncouple, but this, see the little number 2 right here? This piece of steel right here actually uncouples from that joint just before these drawbridges get pulled up. The only reason that these pieces of steel are here is because the weight of the ambulance is too much for the hydraulics to hold. So what happens is the ambulance drives across, then these pieces of steel drop out because they're on joints, and then when the hydraulics push the drawbridges back down, the only thing that needs to come across is this 1.5 polygram scooter. These hydraulics are plenty strong enough to hold up this short bridge if the only thing coming across is a scooter. So let's see it in action. Let's move along. This fucking level, man. This fucking level. I shit you not, this one level right here delayed this entire video an entire week. I spent an entire week trying to do this level better. This quote-unquote solution that I have right here, though it does technically work, it has a big problem. And it was trying to solve that problem that took me a whole week, and I still wasn't able to do it. So let me show you what happens here. The scooter goes, makes it to his flag. Actually, I think it's this flag. Just enough spring tension to keep the tip of that bridge up. The ambulance goes, and the bridge sinks and deforms under the greater weight of the ambulance. This little leg stops it from going too far and breaking the spring. But the ambulance turns turtle, falls forward onto its back, and just barely manages to catch its flag. And this guy catches his flag. Okay. I tried and tried and tried to fix this problem. I shit you not, 4 nights, 4 hours apiece, trying everything I could think of. Let's load up the frustratingly close. So frustratingly close to getting it right. But watch when the very tail end of the ambulance comes off this part of the bridge, and you'll see exactly what happens and what happened basically every time that I tried to make this work. When the ambulance gets down to this last segment of bridge, the springs will pull this segment of bridge upward and flip the ambulance onto its top again. Almost no matter what I tried, this would always happen. I think the person who designed this level knew it because they put the flag right here. Why would you put the flag here and not here? Because they knew that it was basically impossible under this ridiculously low budget to get the ambulance down here. Oh, the other thing that I forgot to tell you earlier on, see how it has 0 roads down here? You only get 1, 2, 3, 4, 5, 6 roads. You only get 6 roads for this entire level, and 6 roads is really not enough to construct 2 bridges. And let me actually show you that. So I did a study, basically built a thing where I used 3 separate... Ignore this. Yeah. So 1 bridge here that tilts up and down, 1 bridge here just to get the mopeds onto there, and then 1 bridge down here that will not flip the ambulance over. And this does work. It's just, you know, 24,000. This is 36,000 out of 24,000, so it's quite significantly over budget. This weird thing up here is just a counterweight. You've got reinforced road counterweight, so that part of the bridge can let the ambulance, the weight of the ambulance, dump it off. but this weight here is a little bit more than the weight of the moped, and so it keeps this earlier part of the bridge up. Okay, so now the question becomes one of, can you delete this? Can you use this thing attached to this somehow to A, only have 6 roads, and B, make some kind of hybrid thing where both the ambulance and the moped can both use it? And the answer is yes, you kind of can. And after hours of tweaking, I came up with this. It's got this total insanity counterweight. Polybridge 2 doesn't show you the weight of this thing, but $10,000 worth of reinforced road up here on this counterweight, and it's ridiculous levels of steel diamonds to deal with the weight and the forces. A bunch of like springs to sort of take some of the weight that the counterweights isn't working for, and this only barely works. Watch how close the ambulance comes to tipping over forward. And it's way over budget. 55,000 out of 24,000 budget. Only barely manages to avoid tipping over the ambulance. And this big counterweight only barely manages to avoid breaking all this steel up here. Yeah, this is terrible. Like, I hate this. I hate everything about it. It's brute force everywhere. And honestly, a big part of the problem is just the placement of this flag. You just put this way too close, which causes the ambulance to stop back here, which causes this to flip over the back of the ambulance and send it turtle. Just bad level design. And they knew it was going to be bad. They gave us way too small a budget. So yeah. There was a guy named Soul Wager on Reddit, and let's flip out to the desktop, and I'll show you what he posted. He posted on the Polybridge subreddit, and he posted this solution, which is, well, you probably can't see. Let's go ahead and we'll click on this and get up the imager page. But before we do, let's just show, he said, just holding the last road flat wasn't enough. Also had to delay the bridge on the way back up to keep it from flipping the ambulance once the front wheels are off the bridge. So let's look at the pictures he published. So here's the bridge in the up position, and it's really hard to tell what's going on here, but basically this last road has a 4-bar linkage. You've got these two parallel links right here that allows it to essentially stay more or less flat even as the rest of the bridge changes shape behind it. And then you've got another triangle here out of wood that's hard to see, but it's there, which has another 4-bar linkage linking it down to this triangle. And that triangle has a bunch of springs and other stuff, and you can see this is kind of crazy and confusing. I couldn't reproduce this, but the upshot of all this stuff is when the ambulance drives down onto these last couple pieces of road here, the bridge deforms like that. Now these two triangles are more obvious, and it allows this little part to stay more or less level. He also says he has some kind of delay mechanism in here so that when the ambulance rolls off, this part doesn't immediately shoot up and turn the ambulance on its front. And he did it for 22,000, which is very impressive. He did it under budget. I tried to recreate his contraption here, but I had no luck. Like, this doesn't work at all, and I clearly don't fully understand how his 4-bar linkages work or how the triangles work with each other. Great job, Soul Wager. You're masterful, and I bow down before you. I could not make it work that way. The only way I could make it work was hours of tweaking and $20,000 over budget. Or, you know, do it the wrong way. Let the ambulance flip over on its front. Long story short, I hate this level. It's bad design. I spent a week trying everything I could think of to make it work, and I couldn't even make it work. And as far as I can tell, almost nobody... I looked through a lot of gallery pages, maybe 20 or 30 pages worth of galleries. As far as I can tell, nobody got this done the right way. The only person I could find was that Soul Wager guy, and I don't even understand how his bridge works. Fucking hate this level. 215 is crap. At the very most, this should have been a challenge level. This should not be in World 2 ever. World 2 is like one step above World 1. Never ever should this kind of a thing be in World 2. Stowaway, pretty simple. This truck drives up to here, and when it does, the Model T has to collect this checkpoint, then the Model T rolls back down and has to get to its flag up here. Pretty obvious. You just have a tilting bridge driven up by a hydraulic that locks in when it gets up here. This solution works. But I didn't really like it, and I think you can see why right here. See this gap in between the top of this bridge? So, although the wheels on the Model T are plenty big and it manages to skip over that, I just didn't like that. And so I said, you know what, I can do better. So then I made what I call not bad. And very obvious solution, right? You just put in a tiny little... You put in a tiny little piece of road right there. And then you just support it with steel. And then when this comes up, it just locks right in. Not complicated. Does work. I also put steel over top of the arches, just to lower the stress a little bit. You can see there's actually some weird residual stress. I think that these two nodes over here didn't mate quite perfectly. You can also see a little bit of a line right there. So I didn't like this. Also, that thing's kind of struggling to get up there. I felt like I could do better again. This does work, but it's not really working well in my estimation. So I went back for another pass. I got it down to 31,500, 63% stress, and just, in my opinion, a chef's kiss of good design, good engineering, and using all the tools that I know how to use. Let's just run it, and you can see how it goes. Oh, before we run it, one thing. 31,500 is exactly 90% of 35,000. I messed with this little steel foot down here that supports the hydraulic until it was exactly that number, just to do a little budget flex to make it exactly precisely 10% under budget. So yeah, here we go. Look at how green that is. There's no residual stress anywhere in this bridge. This node made it up perfectly. And also, since this is less steep, that Model T manages to keep more of his speed on the way up. It gets up easily instead of struggling up. Chef's kiss. Beautiful. And I believe that this is actually the last, 216 is the last level of World 2. So I think when we press this next button, we're going to head up to World 4, because we've already done World 3. And I've been recording for probably almost an hour now, so this is going to be a long episode. You're welcome. Let's see what happens. Next level. So now we're on to World 3, which we've already done in the previous episode. If you want to see what I've done with World 3, this level in particular, I got kind of creative with it, as you can see. So yeah, if you want to look at the previous episode, you're curious what I did in World 3. Next episode, we will be going to World 4. I've already started a little bit on World 4, and I'll give you a quick preview of what I did on World 4. Hope you've enjoyed it. Hope you're staying salty, my friends. Hopefully see you next time.